presencia. A ver si se ven ahí. Muy bien. Muy bien. Ok. Ok. Sí, señor.
Bien, mi nombre es Agustín, nosotros somos el grupo de producción de Xileno, grupo conformado por Agustín Ledesma, Máximo Arias y Franco Sístola. Y este proyecto que llevamos a cabo, donde abarcamos el estudio técnico-económico sobre la instalación de una planta de producción de Xileno en nuestro país, va a ser evaluado por los docentes Luis Gisarelli y Mariana Tamurini. Para nosotros, el año de cursada de esta materia fue durante 2021 y estamos realizando la presentación del proyecto en agosto de 2022. La materia en cuestión es Integración 4, perteneciente a la carrera de grado Ingeniería Química en la Universidad Tecnológica Nacional, Facultad Regional Delta. A lo largo de esta exposición vamos a seguir la estructura que vemos en pantalla, comenzando con un breve capítulo en inglés y después abarcando 7 capítulos sobre diferentes características o cuestiones interesantes sobre el proyecto. So we will start with a short introduction about what is paraxylene, what are the uses of paraxylene, and the properties of paraxylene. Paraxylene is an aromatic hydrocarbon. It is one of the 3 isomers of the methylbenzene, known collectively as xylenes. The P stands for para, indicating that the 2 methyl groups in paraxylene occupy the diametrically opposite positions 1 and 4. The molecular formula is C8H10. Paraxylene is an important chemical feedstock. It is a raw material in the large-scale synthesis of various polymers, and is a component in the production of terephthalic acid, which is a raw material to get polyethylene terephthalate. So, the paraxylene is an important raw material to get terephthalic acid, and terephthalic acid is a raw material to get polyethylene terephthalate. The polyethylene terephthalate, PET, is used to make clothing and plastic bottles, and the 70% of the terephthalic acid is obtained by oxidation of paraxylene in an acid medium in presence of air or oxygen and catalyzed by cobalt, manganese, and bromine compounds. Here we have some properties of paraxylene. As we can see, the shape and color is crystalline like water is, and paraxylene has a higher boiling point than water, also is less dense.
In this next section, we are going to talk about what are the uses of paraxylene, of PET, what is PET, its most important characteristics, and we are going to go over the production of paraxylene in Argentina. PET is the most common thermoplastic polymer resin of the polyester family, and its most important uses are for clothing and containers for liquids and foods. It is obtained in a reaction between terephthalic acid and ethylene glycol to produce the compound known as PET. It is part of a family of materials called synthetic materials. Its most important characteristics are its high degree of crystallinity, for which it is transparent, so it helps with the presentation of contents inside it. and it is recyclable, so it's the most recyclable plastic. It has mechanical resistance, so it can withstand wear and bending. It is lightweight, so it weighs 20 times less than it contains, with helps with transportation and volume that can be transported. Also, it is waterproof, so it acts as a barrier from carbon dioxide, oxygen, and water in its content. So it has another property which is thermal resistant. It can withstand temperatures ranging from -40 to 65 degrees. Lastly, it's approved by the Argentinian Food Code for contact with food, so it can be sold with food. Next, we are going to go over the production of PET in Argentina. The main producer is Alpec, which as a whole company produces polyethylene terephthalate resin, polyester short fibers, monomers, and special polymers. But the plant that is located in Zárate, Buenos Aires, Argentina, is specifically in charge of producing PET. Now we're going to go over the next section, which is technology selection.
Now I am going to talk about the technology selection. We are going to consider the parameters and the two technologies that I am going to develop is toluene methylation and toluene selective disproportion. As I said before, we are going to analyze two technologies, toluene methylation and toluene selective disproportion. And the parameters to be considered are raw material, the process, the temperatures in the reaction, and the catalyst to be used. The toluene methylation, it has a high shield because all the methanols that enter is at 100% conversion, methyl conversion, and it has a high selectivity because the catalyst that is used has a great selectivity to the paraxylene. And the average of the temperature which is in the reactor is 405 degrees. In the reactor enter toluene plus methanol, and the products are paraxylene and water. As I said before, we enter water and methanol, high concentration of methanol, with toluene and nitrogen. The nitrogen didn't participate. The nitrogen didn't participate in the reaction, but it's necessary for the time space in the reactor. The time space is a parameter to have a better percentage of
proportions on the same products.
Yes. Sorry. After that, enter in the separation units, and we obtain water and nitrogen. The nitrogen is recycled to the reaction. After that, we have the purification, and we obtain the paraxylene and the toluene. In the toluene selective disproportion, that is going to be our process. It's a simple process. We need less investment. It's cheap than others. It has a product with high purity. We use hydrogen instead of nitrogen. The catalyst is a zeolite. It has a conversion of 48% and a selectivity of 59%. In the reactor, it's going to enter toluene, and after the reactor, we obtain all the isomers of xylene, paraxylene, methylxylene, and orthoxylene. How I say, the selectivity is 59% for the paraxylene, and we obtain benzene. In the reactor, enter the hydrogen and toluene. and the hydrogen is recycled to the reactor to have a it is used, like I said before, is to the time space of the reactor. After that, we go into the separation units and we obtain one of the isomers, the orthoxylene and benzene. After that, in the purification, we obtain the paraxylene and xylol. The xylol is a mixture of the three isomers of the xylenes and other mixture of compounds. Chemistry behind the toluene disproportion. Now we are going to talk about the toluene disproportion and the raw materials used in the reaction. We convert toluene into xylenes and benzene, as I said before, and the three isomers of xylene can be produced. Paraxylene, metaxylene, and orthoxylene is necessary a catalyst of zeolite that is very expensive because it has platinum and radium. How I said before, we have a greater selectivity toward to the paraxylene. The raw materials are hydrogen and toluene. The toluene react and the hydrogen didn't react in the process.
Now we are going to make some comments about the market study covering the local paraxylene production, the terephthalic acid apparent consumption, and the toluene production. It is important to remind that the paraxylene is a raw material to get terephthalic acid, and terephthalic acid is a raw material to get polyethylene terephthalate. While the market for paraxylene is constantly growing, the local production is currently new. The apparent consumption of terephthalic acid shows a linear increase, and the production of paraxylene is important to satisfy the production of terephthalic acid. The current local production of toluene does not meet the requirements for our project. However, there is installed capacity to achieve it. Let's define then the production rate of paraxylene. A production of 900,000 of paraxylene per year is estimated to supply the proposed terephthalic acid plant in 2021. Now we are going to define where will be installed the industrial plant. The industrial plant will be installed in the same place as the main consumer of paraxylene in the Parque Industrial y Logístico Paraná de Las Palmas, located in Zárate.
Now, how I said before, we are going to talk about the selective disproportion process, and it has three stages: the reaction, the distillation, and the purification. The first of all is the reaction. In this reaction, we have hydrogen and toluene, how we say. The hydrogen, we have 50 bars, and it enters to the reactor plus the toluene. The toluene came fresh from the TK102 that we obtained from IPF. We have a recycle from the distillation. It's exchange heat with the products after the reactor, and we compress it to 30 bars to enter in the reactor. In the reactor, we obtain hydrogen and toluene that didn't react, and the products. The products are paraxylene, orthoxylene, metaxylene, and benzene. All these flow exchange heat with the toluene. After that, we have a separator flash, and we have the hydrogen to the compressor. After that, we store in the TK103 to give to the distillation.
The mixture of xylenes, toluene, and benzene is fed to the first distillation tower, where through the top we obtain benzene, which is ready for sale and stored in the tank. At the bottom of the first distillation tower, we obtain a stream which contains paraxylene, orthoxylene, metaxylene, and toluene, which is fed to the second distillation tower, where through the top we obtain the toluene, which is precipitated to the reaction. At the bottom of the second distillation tower, we obtain a mixture of xylenes, which is fed to the third distillation tower, where at the bottom of this third distillation tower, we obtain the orthoxylene, which is stored in a tank and ready for sale. Meanwhile, through the top, we obtain a mixture of xylenes, which is sent to purification.
In the purification stage, the current coming from this station is passed through a heat exchanger where the temperature is reduced before entering the crystallizer. In this crystallizer, we utilize the differences between the crystallizing points between the isomers of xylene, where the paraxylene has a much higher point of crystallization, so it only crystallizes while it stays in the crystallizer. We then send the current number 23 to a centrifuge, where in the bottom we obtain Xileno, which is a mixture of xylenes, mainly metaxylene, and we store it in this tank ready to be sold. The other current that comes from the centrifuge is the paraxylene crystals, which then move to a melter tank, where they are melted at 25 degrees Celsius, and then transported into a tank where they are stored ready for sale.
Finally, we are going to explain the mass proportions for the process. For every 100 tons of paraxylene, we need 10 kilograms of hydrogen and 222 tons of toluene. And we obtain 94 tons of benzene, 3 tons of orthoxylene, and 25 tons of xylene.